Today I'm going to show you some of the tools that we have in SolidWorks to make plastic parts. This happens to be a case, or actually it's a cradle for holding portable phones. This is an assembly file. There's the part for the cradle itself. There's a display part. There's some buttons, and then there's a circuit board inside. So I'm going to open up the part file in its own window. Features are already built in here, and I can go through some of those. Let's see. Let's maybe look at this in one direction. You see this little piece right here at the snap hook. We actually have a tool that's available to generate snap hooks. If I edit the feature, you can see that basically we just select the point to locate it, and some faces to find the orientation of it, and then put in the dimensions in the dialog box to create the snap hook for us. This happens to be one that holds the circuit board in place, but we can have a snap hook, and then we can also we can have snap hooks to hold two parts together. And so basically we can define a snap hook, and then we can define a snap hook groove. In the snap hook groove, and we use the snap hook to define the groove. We have the mating piece for that. Let's go ahead and turn off my section view. We do have a tool in here. Also notice my command manager. I've got a command manager tab for mold tools. This is where I can hold all my plastic part features that I use for making plastic parts. These are customizable. So for example, mounting bosses and lip and grooves, those are not standard tools in this toolbar, but I can easily drag and drop into this command manager. We have a parting line analysis tool. So if I go to the tool, I can just select a plane. The plane is basically defining the orientation of the part, what direction I'm going to be pulling the part away from the mold. And you can see it automatically found the best solution for us. I could, if I wanted to, I could adjust this if I needed to, but it does it for us, so why bother making changes to it? And let me turn this on one more time and actually hit the OK button. And now you can see where it's actually got it's a dynamic to where when I turn on the tool it stays on. We also have a tool for draft analysis. Again, we'll pick a plane to define the orientation of the part. You can define the draft angle. We could also do a gradient transition, but here basically the green faces have positive draft, yellow have required draft, so they have less than 2 degrees of draft in this case, and the red has negative draft. If I hover my cursor over the part, it'll tell me what draft I have at that particular location. So you can see right there I've got 73.78 degrees draft. And just like the parting line analysis tool, it's dynamic to where when it's pushed in, it stays in, and I can still do my measuring, find out what the draft is at that particular location. I'm going to go ahead and roll down my scroll bar all the way to the end of the part, and you can see I've got this part split in two, so now I've got two bodies rather than a single body, and I use basically that split line to define the location to split the part in two. I'm going to go ahead and turn off my draft analysis. And I'm going to add some more features to the bottom part of this. So I'm going to isolate that body in this assembly, or excuse me, in this multi-body part file, and use one of our other tools, the mounting boss tool. So the mounting boss tool, I need to position it I've got a 3D sketch with a point on that face right here where I want the mounting boss. And you can see where it puts in a lot of features in the model. Also notice the boss type. I have the ability to either do a hardware boss. Hardware boss is where you got a screw holding the two pieces together. And then which is this going to be? Is this going to be a boss for the head of the screw, or is this going to be a threaded hole? I've also got the option to make it a pinned box or pinned boss. And then is this boss going to be the pin, or is it going to be the hole to accept the pin? Well, in this case, I want it to hold to accept the pin. And then I can just key in the information here for the size and all that. Also, if I do have some features or favorites, so I can save a favorite and I can load the favorite, and then I can use that favorite which has all the dimensions for that particular favorite. And there's the boss. So I forgot to do one thing, so I'm going to go ahead and edit the feature. And let's orient the fins. So I want the fins to be parallel to that edge right there. And I can exit the isolate. A lot of times when you're working in parts, plastic parts, we can go to a section view so I can actually see inside the model. And now I need another mounting boss on the upper half of this part, so I can use that same mounting boss. And this time I want it to be mounted on this face right here. But for location, what I can do, I can select this existing circular edge to locate it. And notice, like right now, it's hardware boss. But if I select this edge right here on this boss right here, it knows that this boss is a pin boss. It also knows that the pin boss has a hole in it, so it's going to use a pinned a pin boss for this one, and it's automatically picking the dimensions based off of this other boss, except here I want to select the mating face, and I'll select this mating face of the pin boss. Also, I can select the mating edge, and this will be the edge of the hole in the boss. And right now I've got a gap between it, between the two faces that it's mating together. I do not want a gap there, so I'll just change that to 0 for the gap, and you can see it's touching each other now. Orientation of the fins, this time I'll do it when I'm supposed to, and I'll just select this edge right here, and that should rotate the fins to match. And also, again, let's go ahead and add a little bit more material to this, to the fin, and I can see that my C dimension is the dimension for the fin, and let's go ahead and make that 7, I guess, millimeters. So we got a lot of flexibility. We can edit the definition of these fastening features. Another feature we have is a lip and groove. Basically, a lip and groove allows to put a little groove in here. So I want to create a lip and groove between that body and this body. And I need this flat face here to define the direction of the lip and groove. For the groove section, I want to put the groove in this body right here using this inside an edge, and you can kind of see what a preview of the groove will be for the lip. the lip will be on the bottom body, so it'll be that face right there, the bottom body. And again, I'll use that same inside edge. And you can kind of see it's kind of, so there's the lip portion of this. And I'll just turn off the maintain existing wall faces and hit my OK button. And there's the lip and groove. And if I go back to my assembly, so there's my assembly. Let's do a little section view in here. And let's use this other plane. And that looks like the correct location. And there's that hook holding the circuit board in place. Can also do some interference detection in here. And I do have interferences, but you can kind of see that I've got interferences on the pins on the chips to the circuit board. So I want to turn off, I want to treat sub-assemblies as components. And now if I recalculate, so it's treating this sub-assembly here, the circuit board sub-assembly, as an individual component, and it's not looking at interferences in it. So there's some of the tools that are used to make the plastic parts. I've also got another part here that I've got open. Actually, excuse me, this is a, well, yeah, it is a part file. And this part file, I brought in the part, I'm going to make a mold of this part. So I've got my part file in here. It's an imported body, so you can bring in neutral file formats into SolidWorks and generate your molds from that. And I'm going to just use my rollback bar to scroll down through the features. Here's a scale feature. So you could use your plastic simulation tool to let it calculate the amount of shrinkage you're going to have, and then you can scale your part so that your mold is going to be the correct size, so that when it cools, it's going to shrink, but it'll shrink to the correct size. If I edit this feature, I'm going to scale it around the centroid and have a uniform scaling of 6%. I could, if I needed to, I could have it scaled in different directions, different scale, different directions, or I could tell it where the centroid of the part is also. And the next thing is creating a parting line. The parting line is basically where we just pick where the mold is going to be separated. And you can select one edge and do tangency around it. Shut-off surfaces. What the shut-off surfaces does, it will close off all the openings, so that way you can then generate your mold body. And let's see here, let's hide or show this shut-off surface. So there's a shut-off surface, and you can see where this happens to be a green surface, but it's filling in all the holes in the model. And you can also see that it can do complicated geometry, also fill those in. If I edit the feature, you can see there's the edges that it's filling in. So it also created two surfaces, one for the cavity and another one for the core. Now the core is red. To make it a little clearer, I can hide my solid body, so now all you see is the surfaces, the two surfaces. Then the next step is creating a parting surface. Go ahead and show the parting surface. So there's our parting surface. If I edit the definition of it, basically how we want to propagate the parting surface. In this case, we want it perpendicular to the pull direction, and we specify the distance or the width of this parting surface, and how to smooth off the corners. The next step is a tooling split. Tooling split is a nice tool where it actually creates the two tool bodies, the core and the cavity bodies for you. So I edit this feature. Here it's using that parting surface to define the length and width of the mold, and then you got pull arrows and dimensions here to define the thickness of the core and the cavity. And I'm just going to hide a few features here. Don't really want to see the surfaces anymore. And let's hide some of these bodies here. So let's hide. So now there's what my tooling split. Now this particular mold needs a side core, so we can mold in the holes or slots on the ends of this thing. Our side core. If I edit this feature, basically we're using a sketch to define the side core. Need a direction to find how we're pulling the side core out from the mold, and then some other features here in the draft, things of that nature. So there's my side core. Core pins. Basically I'm just using a sketch with some circles in there to define the pins, and other faces in here to define how deep the pins are going into it. Next feature is ejector pins. So basically these are the pins to push the part away from the mold. So again, another sketch to define the location of the ejector pins, and the faces to define the depth. And this is just a regular cut extrude in the mold to hold basically I guess you could say the head of the pins, ejector pins. Here's the boss on the ejector pins. And then what we got here, we were saving all these solid bodies, the 15 solid bodies, as an assembly file and individual parts for the individual bodies. So that way we can then explode it and detail out the individual parts in the assembly. So that's all the tool, or some of the tools. Again, there's many tools in SolidWorks for making plastic parts and making molds, but this is just one method that you can use, and some of the tools that you can use to make plastic parts. I thank you for listening.